And the point of with these webinars is to have experts from different parts of the world, both from Kenya, from other places in the world where we can lay our hands on, to come and talk to us, have a discussion with us, help us build our competence. And today we have with us Dr. Seble Mekonnen. She's a technical safety and working environment engineer, and we're very happy that she agreed to come to be with us this evening and make a presentation on health effects of noise exposure, addressing health hazards resulting from exposure to noise at workplaces. The good doctor has long experience working in different areas, and she has a very solid background from the oil industry. She will tell you a little bit about herself when she starts. So she will be talking with us. First, we'll have the presentation, and once the presentation is done, we'll have a round with question and answers where you can ask the questions which you have to the doctor. You will notice that all of you are muted. This is to avoid disturbances, some background noise disturbances. When the doctor has finished with her presentation, we will unmute you and you'll be able to ask your questions. Alternatively, you can write your question in the chat. As I mentioned, this is the first of the series for 2023. We will be planning other webinars as we get more speakers. So if there is a topic maybe you think will be of interest to you and to other safety professionals, you can send an email to us, or you can write in the comment in the webpage where you logged in, and we'll try to see if we can get an expert to take that presentation. So without much ado, I will hand over to Dr. Mekonnen to give our presentation, and then at the end, as agreed, we'll take some question and answers. Please, Doctor.
Hello, everybody. It's great that you all joined this presentation, which I am going to give about the health effects of noise exposure. Thank you so much, Abdul Qadir, for inviting me as guest speaker for OSH Pro Services. And I hope this presentation will help the HSE professionals in Africa during their everyday work life, so that they help workers in every day to make the working environment better and healthier. So the title of my presentation, as I said, is the health effects of noise exposure. It will address the health hazards resulting from exposure to noise at workplaces. As Abdul Qadir told you, I have several backgrounds. I have worked in both land-based and oil industry. One of my backgrounds was in working as occupational hygienist. And during this period, I got extensive, knowledge about workers' health effects due to noise exposure. And it's very important that we address this because there are millions of workers worldwide which are exposed every day to noise in their working day. So I will start with the defining noise, and then I will define sound and tell a little bit about hearing mechanism, and then what are the risks and consequences of noise exposure. And then what regulations do we find in the world about occupational noise exposure? And then how do we control noise exposure? And then we'll talk about a little bit about hearing protective equipment, protection equipment, and then databases some of the databases that exist today for calculating occupational noise exposure. There are so many databases, but I will just mention very few ones. And then finally, I will talk about measurement of occupational noise exposure. How do we measure noise? And then state a little bit about audiometry. So what is noise? Noise is any unwanted sound. It could be very loud music coming from your neighbor, or a speedy car, or anything that it has a lot of unwanted sound that you don't want to hear and which could be very irritating. And it's divided into two types. The first one is the annoying sound, which could be a irritating noise from a ventilation or from a loud music or from a speedy car, which we can live with. And the other one is the harmful noise from noisy environments, working environments, or other environments, which could damage our hearing. And it usually has a noise level of more than 80 decibel A, which is the average noise in terms of 8 hours, or it has impulse noise or a peak noise level usually is over 130 decibel C. And what is sound? When we talk about now noise, I said it's an unwanted sound. So sound is, in order to hear, one must perceive a sound, which is a very important factor in communication. And it's a mechanical wave that is an oscillation of pressure transmitted through solid, liquid, or gas composed of frequencies within the range of hearing. So here in the picture, you see waves of various frequencies. And when we talk about sound, there is a physics of sound. We have the amplitude of sound, which is the volume of the loudness, which is measured in decibel. And then we have the frequency, which you see in this diagram, which is the pitch in hertz, which is the number of oscillations per second. And then you have the wavelength. And we don't hear every sound. Humans perceive sounds between 20 to 20,000 hertz. Normal speech usually is between 200 to 4,000 hertz. And we have what we call infrasound, what we cannot hear, which has a very low frequency, less than 20 hertz, which can be heard by elephants, if you see in this diagram. And then we have the ultrasound, which is sound with very high frequency, which is over 20 kilohertz, and it could be heard by bats and other species. These two are examples. So in the physics of sounds, we have a sound pressure level, which is presented as decibel, and it's a logarithmic function. And sound pressure doubles with an increase of 3 decibels, and the sound pressure is perceived by humans as twice as high with an increase of 10 decibels. The sound pressure level is decreases by 6 decibel when the distance to the sound source is doubled. And we have what we call sensitivity area of the ear, which is the hearing threshold, which is 0 decibel. And then we have the pain threshold, which is 130 decibel. So humans perceive sound pressure level between 0.0002 to 20 Pascal. So if we go over 100 decibel, say, the peak sound, it will be painful, and we might most probably end up getting a hearing loss, and it could be grade 1, grade 2, or grade 3, depending how near we are to the sound source. So here you see different sound pressure levels that is coming from different activities. I just wanted to show you the sound levels. For example, when we speak, It can be 60 up, between 50 to 50 to 70 decibel. Or it can be actually less, actually, if we whisper. Or you have other things like cars or jets, which have high sound, which can be 110 decibel or 120 decibel or more. So which means that when we are in a place or in an area which is over 80 decibel, it's not good for our hearing, basically. And this is what you see, the danger zone. You have the legal action level, the 80 decibel, the average one during 8-hour period. And when we go above that, the more we are exposed to it over a long period of time, or a short period of time, if it is a very high sound pressure, it's not good for our hearing. And when we talk about sound, we have what we call the hearing mechanism, and we have our ear. And in our ear, we have several organs. We have our outer ear, the middle ear, and the inner ear. And you'll see the organs, the different organs here. So what happens is that the sound waves go through the outer ear, and they will reach the organ which is called the tympanic membrane, and they pass through the malleus or incus and the oval window, and they will go to the inner ear. In the inner ear, you have a structure called cochlea, and the waves will go there, and then they will vibrate structures which are found in the cochlea, which I will show you in the next page. So as soon as the sound waves reach our ear and are transmitted to the oval window, the entrance of the cochlea, the fluid in the two scalae and basilar membrane are set into motion, and the basilar membrane is moved by the traveling wave. And then we are able to see if it is on the frequency of hearing of human ear. So you will have different frequencies in this cochlea. You see where the frequencies are located. So what does happen when we have a hearing impairment? When will it occur? It occurs by several cases. Like you can have several reasons, either one or several. So the first one, like I said, is a prolonged noise impact, occupational noise exposure. With a person working is exposed to a high noise level over a long period of time, which is more than 80 decibel, the probability that the person will have hearing damage over years is high. And then the other one is hearing impairment by impulse noise with a peak noise, which is over 130 decibel. And then it could be explosion, it could be strokes, it could be gunshots, for example. It can cause immediate hearing damage, loss, and chronic tinnitus. And the other one is adverse effects of drugs and poisons that are toxic to the ear. They are called ototoxic substances. Example, you have toluene and styrene and xylene. So people working with these chemicals are at risk. The other is accidents, for example, causing head injuries. And the last one is infections. If you have bacterial or virus infections in the ear or along the nerve pathways from the ear. So here you see the hairs in the electron, using the electron microscope of normal auditory cells. They are found in the cochlea that I showed you earlier. So the left one shows at the normal auditory cells, but the right one shows us that these hairs are damaged due to the high frequency and the high pressure sound level. And as you see, the hairs will be removed and they are not able to grow back. And that person having this will have a hearing loss gradually. So the more hair loss will cause the more risk of hearing damage at a higher level, which is called the grade 3 hearing loss. So hearing impairment, for example, according to the Danish Labor Inspection Authority, they have researched if people are exposed, the noise exposure load in the workplace in 10 years is only 80 decibel, there is 0% risk of hearing impairment. If it is 85 decibel A, which is the average, there is 4% of risk hearing impairment. And if it is 90, there is 11%. So this is using, they have studied people working and they have gathered statistical data, and they found out that if it is over 95 decibel, there is 24% risk of hearing impairment. So what are the consequences and the risks? It's very, very difficult to hear and understand signals. Danger and warning signals can be missed. If you have grade 1 hearing loss, you might miss something. You might misunderstand signals, and then the employee might be distracted and then stressed, which increases the burden and the risk to make mistakes in work that requires attention, which means there is high risk of accidents. So I wanted for you to see this NAPO film, which is made by European agency, European Chemical Agency. They have several films, animation films trying to explain damage to noise, chemicals, ergonomy, and several other working environment factors. So this is one of the examples of the NAPO film, which says "Stop the noise." Can I show it, Abdul Qadir, or should we just continue and then we'll see it at the end, maybe? But it just will show, people, teach people, employers can show, or occupational health professionals can show this to employees to make them aware of hearing loss. And what is the direct effect of hearing loss? It is, of course, impaired hearing and sleep disturbances, communication disorder, or one can have a difficulty in speech comprehension, concentration comprehension, and of course, like I mentioned, contribute to stress, even if the noise is small, if it is irritating. And then indirect is, of course, embarrassment. There is social isolation, so people will develop behavioral change. And then you have health effects like heart, vessels, stomach, intestines, stress, and so on. And then sleep loss over gradually, and work performance. We will have a lower work performance. We will have, lower accuracy, and we have risk of error and lower efficiency. So we will be the health challenge associated with noise will be, of course, the first one is social isolation. We will be socially isolated over time, and then we will be very tired, and we will be annoyed, and because we will be under stress all the time, and we will have higher blood pressure. It can cause a change in the heart rate and respiratory rate because we'll be stressed. We will have a change in the brain activity and muscle tension. It can cause muscle tension and digestive upsets. And then it will negatively influence an unborn child. If a woman is pregnant and working in a very noisy environment, the child will be affected in addition to the mother. And you can see all these sites I have mentioned here which mention about health challenge associated with noise. The first one is the NIOSH, the CDC, Center for Disease Control and Prevention. There is a lot of information you can read there. And of course, you have the HSC UK. You can go there, and then the British Occupational Hygiene Society. And then I also picked up something from Safe Work Australia. So you have different countries, different organizations, and they try to mention something about noise. And the NOAA is in Norway, and they have a database about noise. And of course, you can see also other international labor organization, among others, have a topic about noise and how to, protect employer from damaging noisy working environment. So which factors determine the risk of hearing damage? Of course, the volume and the sound pressure level, the exposure time, how long, the frequency, hearing rest, because if you hear a very loud sound continuously, then it will be very damaging the longer it will be. And then individual sensitivity, some people can tolerate a little bit more than the others. And the effect and the type of personal protective equipment. If the employer will give the employee available personal protective equipment, the better the equipment, the better the protection. And then the maintenance of the personal protective equipment that will be given to the employer. So when we talk about regulations about occupational noise exposure, not all countries have the same rules, regulations, and standards about occupational noise exposure. The rules, standards, and regulations, they vary from country to country. And most are based on permissible exposure limit and a time-weighted average exposure. So the time-weighted average exposure is the average noise exposure as integrated over an 8-hour monitoring duration. This is because workers usually work 8 hours. So that's come as a reason for developing the standards and the rules and the regulations. And then there is a requirement. Most countries have a requirement to measure the noise exposure, occupational noise exposure, using a dosimeter, an instrument for measuring noise exposure, personal noise exposure. And then there is an obligation to offer hearing protection if an employee's time-weighted average exposure is at or above the actual level, which is 80 decibel in most countries, and to require hearing protection if it exceeds the permissible exposure level or the employee has suffered a standard threshold shift. And in some countries, a maximum of 140 decibel C, or the peak noise, is allowed, whereas, for example, in Norway, the maximum level of peak sound pressure is 130 decibel C for impulse or impact noise or peak noise. And here are some regulations about occupational exposure, noise exposure in US. You have NIOSH, which is the National Institute of Occupational Safety and Health. And you have OSHA, which is the Occupational Safety and Health Administration. And then you have the ACGIH, the American Conference of Governmental Industrial Hygienists. So not all of them have the same limits. You see, for example, NIOSH has the real labels, which is the recommended exposure limit. And then OSHA has the PL, which is the permissible exposure limit over time. And it's time to reach the noise dose. It rates 8 hours. 85 decibel A is allowed according to NIOSH, but OSHA recommends 90 decibel. And so on for 15 minutes, 100 decibel A, it should not exceed 100 decibel average, whereas OSHA says 115. And then you have the NIOSH, no, the ACGIH, and they have the threshold limit values, you know, the occupational hygienists and industrial hygienists, and they have different labels for 16 hours to 82 decibels to 15 minutes 100 decibels. Basically, according to my experience, the lower the level, the better, because the more higher pressure of noise, you know, more exposure, more peak, then there is a more chance of getting you know, hearing impairment over time. So the best thing is to avoid noise as much as possible during work. And you have also the other table in Norway, the regulation about occupational noise exposure. You have the action limit, and then the recommended maximum level. And then you have groups, group 1, 2, and 3. Group 1 are people working in offices, and the average level is 55 decibel during the noisy 1 hour, whereas group 2 are people working with noisy instruments for a couple of hours a day, and not very high noise instruments, but you know, for example, instruments in the laboratory that might have a lower level of noise, and the actual level is 70 decibel, whereas the recommended level for 1 hour is 60 decibel. And then you have group 3. So these are people working with noisy, you know, with noisy machines and instruments during their work hour, during 8 hours, that should not exceed 80 decibels, the action value. So if they are over 80 decibel, they should have personal protective equipment. And then you have a limit value, which is the daily noise exposure is 85 decibel average, whereas the peak pressure, sound pressure level is 130 decibel. And they recommend that the maximum level is actually 75 decibel average. So what about UK? You have the Health and Safety Executive UK. It has a different, it has similar but a little bit different values in terms of the peak sound pressure. For example, here is the upper exposure action value is 137 decibel. And then the daily or weekly exposure noise pressure level is 87 decibel. And then the peak sound pressure is 140 decibel. And then you have legal responsibilities also in Norway, which is illustrated here in UK for assessing risks and informing workers in terms of training and health surveillance and use of personal protective equipment. And this is also relevant to most European countries and you know, US and some countries in Africa. And there is action limit value. You see here the noise action limit value in UK, 80, 85, and 87 is like the legal limit. And in Norway, I mentioned it earlier, for 12 hours, it's corrected to 83 decibel, which is for offshore in terms of the facilities and the activities regulations. And then you have the Norwegian Labor Inspection Authority, where Abdul Qadir is working, and you have regulations there concerning action and limits values. And in there, you have a law which states the exposure level, which is stated here, which is 80 decibel average and peak level of 130 decibel. And hearing protection training must be given over 80 decibel exposure in over 8 in which exceeds no in which where people work during 8 hours. So here are some of the labels in Norway in terms of hours. I showed you earlier tables from US, from different organizations in US, and here in Norway you have 8 hours 85, the limit value, and then if you work 4 hours you have 88 decibel. It should not exceed, and they say if you work 2 hours you should not exceed 91 decibel, and so on. And then if you have impulse noise, you have the exposure time in seconds. So the limit value for impulse noise is in basically when it's 100 decibel C, it should not exceed 0.9375000 seconds. So if it is over that, the risk of hearing loss or damage is high. And there is, of course, you see the warning signs. So there are in places where people are working and exposed, there will be warning signs and hearing protection signs. Here is the one of the regulations or guidelines of the Norwegian Oil and Gas Association, where they have a table according to noise hazard safety sign and maximum sound pressure level and the limit values in area classification. So people working offshore, they usually have to follow this noise classification and use of, for example, if they work more than in an area which has more than 95 decibel average noise, they should have a double hearing protection, and they should not be there more than 10 minutes, basically, because it's dangerous for their ear. And the same with the peak label. They should have a double hearing protection equipment, and they should be there 10 minutes, and they should leave the area. And of course, you have single hearing protection if you have over 80 decibel average level up to the 95 decibel. And then you don't have no noise or safety signs if the area classification is less than 80 decibel. And then you have also I think it's the same table I'm presenting here, so you can look through it, and then it says about maximum residence time per shift. So how many hours per shift are they supposed to work? That's the difference between the earlier and this table. So it's recommended that if they are in an area between 96 and 100 decibel average, they must work 6 hours per shift. It's recommended. And they must have a double hearing protection, both earmuffs and earplugs when staying for more than 10 minutes. For shorter stays, single protection, and so on. And what do we do when we control noise exposure? So current measures control noise exposure and combat the noise risk can be classified into 3 major steps or actions. The first one is removing the noise source. So if we have an equipment that creates a lot of noise, is it possible to remove it and substitute it with an equipment that has less noise? Then if it is possible for the company or for the employer, then the employer should implement it. That's the best method to avoid noise exposure. And the second one is technical and organizational measures towards noise exposure. So is it possible to isolate the noise exposure? For example, if you see here, you have isolation of the equipment in the diagram. You see the blue structure is there to make so that the noise should not go out of the area to the people working outside in the area should not be hearing the noise that's coming up from the machine. And the people who will be working, for example, repairing the machine, will must probably use a double or a single hearing protective equipment while they are staying inside the area near the machine. And the other is if there's a vibration from the equipment, can it be muted? Because vibration also have effects for health, negative effects. And the other one is, can we use silencers in the equipment itself? Can we make like the fan speed, if they have very speedy and make noise, can we put something there? And noise absorbing materials near the noise source. Good maintenance of equipment and parts can help to reduce the noise. If the machine is very old and noisy, then it needs more maintenance. So keeping up maintenance will help us. And then can there be change in the workplace? For example, by installing sound absorbers to reduce the echo effect from the walls, the ceiling, and the floor. Can work be planned? For example, by selecting work methods and work hours resulting in less noise exposure. That's organizational measure. And then how and where the work equipment is installed and placed can be very important. Is it placed near where people are working? Is it far away? So we have to place it as far away as possible from the area where employees are working regularly. Otherwise, we have to isolate it. And then does one have good enough hearing protection? The hearing protection that the employer provides or the employee has, is it good enough? Because there are thousands of hearing equipments out there, and not all are the same. And the maintenance, the hearing protective equipment, it needs also maintenance regularly. Otherwise, it will be worn out, it will be old, so the protection will not be good. What about employees? Have they be given, teaching, training about the health consequences of noise? Do they know about it? So it's very important to make them aware as early as possible. And what about the ones who are already have hearing impairment? So if they have grade 1 hearing impairment, it's better to place them to another place, to another department, so that they don't work with the same noisy equipment and work another 5 more 10 years and then develop grade 2 damage. So it's extremely important. That's also an organizational measure. So the third one is to equip the workers with hearing protection equipment. So this is the solution that can be selected after the previous two have been tested. So after, if it's possible not to remove the noise source or make a technical or organizational measure, then the third choice we have is, of course, the employee should have hearing protective equipment. That's the only way. If he or she is working in an area which is very noisy. And this is, of course, the weakest and the least satisfactory solution to the work environment issues, but sometimes there is no choice. The equipments are noisy and it's not possible to isolate them. So, so the other things that is important during the control of noise exposure is we have to provide monitoring. The occupational hygienists and HSE professionals, industrial hygienists, they will provide periodic monitoring for noise to ensure workplace conditions remain unchanged, resulting in exposures below the permissible exposure limit, and then maintain an accurate record of all monitoring conducted to comply with governmental requirements, identify exposure scenarios, and perform appropriate evaluations to protect employees and reduce employee exposure to noise, utilize adequate engineering controls to continually reduce employee exposure to noise and document those efforts, and then provide training to noise exposure, equipment, machine usage, personal protective equipment, and etc., and to employees on a regular basis and document these efforts. So the training should be continuous because there will be new employee coming in, for example. tomorrow. Then he or she should be trained of the health effect of noise when it's possible. And this is usually done using occupational health service companies, or the company will have internal occupational hygienists or industrial hygienists or HSE professionals which are responsible for this. And then there will be audiometric hearing testing to exposed employees, and that depends from country to country. And of course, and this audiometric hearing testing will be done by, doctors and nurses. And usually it's taken in Norway, for example, it's taken every 3 years. People which are in group 3, people exposed to noise, will have audiometric testing every 3 years, controlled to see if they have developed hearing impairment or not, and then to avoid that during their lifetime. And when we talk about hearing protection equipment, it's like I said, there are several types. So I have copied and pasted the ones that are available on the internet. And the basic ones are earmuffs or earplugs. You have earmuffs or earplugs. And you see here a lot of earmuffs, depending, they have different type of protection depending on the producer, and they have also it's called form, the one which goes directly to your ear, not an earplug, but the third one, the illacin that you see here, can be actually goes directly to your ear. They measure the outer ear and the middle ear for an employee. For example, if an employee is able to afford it, he can get this type of earplugs, which can go directly to the ear, and they work the same way as earmuffs. But they are usually expensive and are provided by some employers, and some not everywhere in the world. And so the best is, of course, to get the best protection equipment if possible, and follow the routine of what it says in the equipment, how you can repair it, how long you can use it, and so on, and follow that to get the best protection. And most of the earmuffs, they can reduce the noise up to 25 decibel or more. And some you see here, noise reduction of 30 decibel or more, and the earplugs. So it depends on the manufacturer. And I know that Peltor is one of the most famous ones, and you have 3M and so on. So there are several ones. And how you set the correct earplugs is also very, very important, how you set them into the ear. The Norwegian Oil and Gas Association has a video showing how you can set the earplugs correctly into the ear. So I advise all of you to see this. Maybe we can watch it later when we are finished. We have 2 videos to watch. And how we set earmuffs is also very, very important. They must be completely tight, seal against the skin around the ears. And they must be, the pillows and the feeders can age inside the earmuffs. If you see in the diagram earlier, you have on the left bottom corner, you have the pillows you see inside, which are found inside the earmuffs. They will age over time, and they must be replaced. And in Norway, it is recommended usually, the Norwegian Labor Inspection Authority says 6 months. So if you see them worn out, it's better to replace them. And then earmuffs can be unsealed in combination with safety glasses between the skin and the earmuffs. So it's very important to have the safety glasses in a correct position to avoid that. And the safety glasses with thin rods, face shields, or helmet with integrated goggles will reduce a leakage. So you have an estimated attenuation for single and double hearing protection. Here in Norway, it's 12 decibel for single protection and 18 decibel for double protection, which means earmuffs and earplugs. That is depending based on the fact that the earmuffs have a single number rating ratio of 30 decibel, whereas the plugs have single number rating ratio of 35 decibel. And that is found in the information sheet you'll be given by the producer of these earmuffs or earplugs. So if you get one from Peltor, for example, and then if it says that if it has more SNR more than 30 decibel, then it is good. So and then in a places where you have this, you everywhere in the world, mostly in most countries, you have these warning signs, and they might be different depending on the country. But the most important is that the employee or the worker should be aware of these signs and should be trained and should use the hearing protection properly and maintain it properly. Examples of noise sources is, for example, this is an instrument. This is a picture. You see one high pressure instrument where the person is working with. It definitely will have a noise more than 100 decibels. Ultra high pressure jetting, you see it's 101 decibel. So it is really not only it has high noise, it might also vibrate. So it's it's very important to know how to use it and to know personal protective equipment, including gloves. You see the employee not only has hearing equipment, but he also has gloves. And then you have sledgehammer and tiger saw, for example, which is 101 decibel, and grinder 109 decibel. So all this, this sponging is an operation which can create a noise of 117 decibel. So it's very important that workers working with highly noisy equipment and machines should use protective equipment. And how do we calculate theoretical noise exposure? For example, if we work with a grinder, which has 100 decibel average noise for 30 minutes and use a double hearing protection, and then work in remaining of the rest of the day in a quiet area, then it means 110 decibels minus 18 decibel, 92 decibel at the ear for 30 minutes, which is equivalent to 89 decibel for 1 hour, 86 decibel for 2 hours, and 80 decibel for 8 hours. So we must, the employee must not exceed these 30 minutes. So if he or she has worked over 30 minutes and with a grinder, which is 110 decibel, then the chances that the average noise is more than 80 decibel for 8 hours is high. Of course, it will be more. So he or she will end up with impairment after a long period of time. And there are several databases for calculating occupational noise exposure. One of the databases I found is the HSC Executive database. You can go into the site and see the noise exposure calculator. You have Excel sheets also from Canada, where you can put, how many the noise level of the instrument and so on. It will give you the exposure time and minutes. And the same in UK, and we do have also one in Norway, but I thought the one you can read the one in English. You probably know the HSC Executive more. So you can use this one to calculate the hearing protection calculators, for example, and so on. So these are examples from, showing different organizations and regulations. This is in US, the OSHA regulation, the NIOSH, and then what is in Europe, and so on the custom. So you can actually calculate where you might calculate where you are. You give your location and then the sound label, and then it will give you the exposure time in hour and minutes, and partial dose of time weighted average level. So I thought maybe this is also interesting site to see, but you find, of course, like I said, a lot of databases. So I encourage you to go in and look and find out and give information to the employees, help employees, when you are giving trainings. And of course, most of you know about how noise, occupational noise exposure is done, and probably performed it. And you have several standards in different countries. In Norway, you have, the NURSOK standard, Norwegian standard for working environment that should be followed, and then other standards mentioned here. But you have three methods to measure noise, and currently mostly occupational health professionals, industrial hygienists use the conventional audio level meters, which have a microphone and a microprocessor. Results are displayed directly on the display. You can see he's holding it in his hand, and there are procedures to follow when measuring this according to standards. And then you have the noise dosimeters, which are measuring the occupational personal noise exposure over time. So this example is from Casella. This is the Casella dosimeter. And it's very easy to use, and one can one can go to the workplace, talk to the workers, and then find out how much noise they are exposed to in terms of 8 hours or 12 hours using these instruments. And the other one is measurements of echo or start pistol with a common gunpowder. I haven't used this method, but it's also one of the methods used. So I encourage you to see these YouTube presentations on how to measure noise. There are several presentations out there by different companies, and probably most of you know about this, but you can watch some of the videos out there. And the last topic is, of course, the audiometry or hearing checkup. So the audiometry or hearing checkup will depend from country to country. And like I said, it is for people who will have occupational health exposure. So this is to find out if the employees have, suffered from hearing loss over their, occupation, in their occupation of maybe 5 years, 6 years, 10 years. But here in Norway, every 3 years, people will take the test, and it shows the individual's hearing threshold at most appropriate sound frequencies. And then it is usually performed by healthcare professionals with the calibrated equipment that you see here. And then it will give you, when the healthcare professionals, the doctors and the nurses, after they do the test, they will find out if the person have hearing loss with the graph shown here, where it shows the sound pressure level and the frequencies. So you will be tested to hear different levels of sound, different frequencies, and then you will be asked to indicate, put a, click when you hear a sound, very low sound, and then the sound will be very low and at different frequencies. And then if a person has a damage, hearing damage, hearing loss, usually one can see it between in the frequency label shown here. You see you have a normal, and then you have a person having grade 1, and then no, the normal, sorry, and then the second one, which is the gray one, is a person which has suffered grade 1 or 2 noise damage, and it shows at 8,000 hertz. He cannot hear it. The graph goes down. And then the third one is a person with probably hearing impairment. So like I said, hearing impairment is irreversible. Like, one cannot get the hearing mechanism back. So it's very important. And this audiometry, or the hearing checkup, it's used for early detection of hearing damage and development. Data is used for advice. And then in Norway, it's used for notification of the relevant authorities, the Petroleum Safety Authority for offshore and the Labor Inspection Authority for land in case of Norway. And of course, if there is a possibility of employee relocation to reduce employees' further noise exposure, because she will develop more exposure if it's already showed in the audiometry that she has grade 1 impairment, and then if she's working another 3 years there, gradually he or she will end up with a hearing loss. So it's very important to have audiometry. So with that, I say thank you, but I want to show you the videos. I want to show you first of all the NAPO video, which I think is really interesting. I want you to use these videos when you are training employees, workers, because they have very, very interesting funny videos there. And it will help people to learn. So I think it's important that you do that. I don't know if you see my. Do you see my? Yes, of course you see it.
Oh, we see the same the presentation, not the video.
What did you say?
We see the presentation, not the video.
Okay, then I have to share the. I have to go back. No, what did I do? I have to go. I have to stop this first. How do I'm not?
If you share your whole screen, then you can pick what you want. You can close down this presentation and then show the video will come up.
Share my whole screen. It says stop presenting. So should I stop? No, I can't.
Yeah, you can stop. You can stop presenting, and then
okay.
you can, then you can share
present
again.
now your entire screen. Yes. Share. Why is it not? It's not making me able to the entire screen.
Go to the present now again, and then
window maybe. But if
try present in the window where you open that video.
Yeah. Okay, window, and then where am I? I don't have NAPO. Of course I have NAPO here. Yeah, here. Share. You're preparing your screen. Do you see NAPO now?
No, we see your screen as it is. Everything on your screen, but not NAPO.
Okay. Now, do you see NAPO?
Yeah. Yes.
Okay, then I think it's shown very as big, but still.
There's no sound, but I think since everybody will get the presentations and they
Yeah.
have the links and they can take their own time and look at them. So
Okay. Yeah, no problem.
yeah, because that will be the easiest. That when they get the presentation, they can access they can copy the link and watch them at their own free time, and so we save a little bit time on that.
Yeah, and of course here it says Norwegian, but you go and then this is international. You change it to English, you find everything in English. Basically, stop that noise, and then it's not only noise. Like I said, it has several videos. You know, and it's very interesting. You know, and it's very funny, but also helps the HSE professionals and occupational hygienists, you know, to in the training to use this. I mean, and then of course you have a lot of the other video sites that I mentioned earlier. So you also have a chance to go in and look. So with this I say thank you for the listening my presentation. But if anybody has a question, of course you are most welcome. This is I have to go and share my presentation again to all of you. So this is time for questioning.
Yes.
Yes.
And with that, I've opened a possibility for you to unmute yourself and ask the question. So if you have a question, please raise your hand from below. Then and then you can unmute yourself and ask your questions. Alternative, you can write your question in the chat, and we will read it. So it's your choice. But while we're waiting for questions, I want to make a slight comment. We started last year. We had a project with some metal workers in the informal sector, and we did some noise level monitoring. The levels were around from between 96 to 105. And they experienced this for over 10 hours a day. Oh. And we took some of the workers, those who volunteered, we took them to an audiologist. They were tested, and 9 of 12 were recommended to have hearing aids because they had lost their hearing. And when we talked to them, one of them said that people think that he's rude because when people talk to him, he doesn't reply.
Yeah.
But the problem is that this poor guy doesn't hear. He was the one who was most affected, and the audiologist recommended that he gets hearing aids. But these are problems which you see very much in the informal sector. And so that's why we started actually that project in the informal sector, and we had we bought some earmuffs which we gave to them, and I went back after a few months, and they were very happy to use them, and they were feeling at least somebody has taken care of them. So these problems are real, and we see them on daily basis in different workplaces. So in an industrial setting, you'll have the safety officer who will be doing checks here and there. But in the informal sector, things are a little bit different, and there is no control completely. So I just wanted to mention that. And then another thing which I read in a publication from a university, the PhD candidate in Kenya, who wrote. Actually, they did noise monitoring in the same places we visited, and I think the the limit in, I'm not sure about this, maybe somebody in the group can correct me, but the limit in Kenya is set at 90 decibels average. So we see that in other countries already at 85, that's action level. But in Kenya, we have a limit at 90, which could be very high considering that other countries have action level at 85. But maybe somebody in the group knows about these actions a little bit better than me. So, any questions? I can't see anybody asking or raising their hands. If you have a question, if you have a comment, if there's something you want Dr. Mekonnen to explain again, you can unmute yourself and speak. Feel free. I can't see anybody asking for the floor. So as long as you're not asking for the floor, I'll continue talking. The presentation will be available. Actually, it's already available on the same page where you logged in. The presentation is there, and in a few days, the video also will be posted on the same page. You can go and look at it again. It will be also available from YouTube. You can look at it. You can share it with those who think will benefit from it. You can use it as a basis for your training. So it will be there. Yeah, Evelyn, please.
Okay, I have a question now.
Please.
There's some team which were done the audiometry, and then there are some results which were showing that they have mild hearing loss. And then when I talked to the doctor, he talked of there's a curve you've shown during the presentation, and he indicated that according to him, it is not occupational related. Is there something like that? That someone could be losing hearing, but it is not occupational related?
Yeah, of course, it can be not occupational related because, like I said, cause of hearing loss can be several factors. And one of the factors is, for example, using medication or bacteria or virus infection in the ear can be a cause. It could be also working with the chemicals, but that is work related, that is work related. Or it could be accidents, car accidents, for example, head injuries, like if a person has. So the first one is, of course, occupational. Here you see prolonged noise impact. If a person is working in a noisy environment over the time, a long period of time, if these people, but maybe these people have been also, do they use drugs? Could be also a reason. If that person was using drugs or has taken poisons that will be impacting the hearing impairment, it could be the reason, of course, or it could be that that person had already head injuries from before or has been infected with a bacteria or virus from before, or had been exposed to explosion, not work related. I mean, not everything could be work related, but it at the same time could be most people will have here in Norway, it's work related. Hearing loss, hearing impairment is one of the major working environment factors that's affecting workers' occupational health noise exposure. And I mean also in Africa, there are millions of people exposed to noise. And we do have, of course, training and checkups and so on, but we are not we don't have the money or the resources or the capacity to follow noise hearing impairment as Europe or US. So there will be several people which has this. So I encourage all of you to make sure that the employees usually don't have training. So it's good to give training, and it could be that the employer also don't have money to provide the personal protective equipment. So it's we must do our best in our profession to protect the workers, inform the employer also. It's very important. So he could be right, the doctor could be right. So yeah.
I mentioned about the 90 decibel level in Kenya, and there are some clarification in the chat from Samuel, Samson and Samuel. Thank you very much for that. You can those who want to can read in the chat. Are there any further questions? Evelyn, do you have another question? Your hand is still raised.
I think in Kenya you are using the UK regulation, or is it?
No, there is an
Separate.
OSHA regulation, a
OSHA
Kenyan
regulation.
regulation.
Yeah.
It's OSHA Act of 2007.
Yeah, the
And
occupational health.
there is so the Directorate of Occupational Safety and Health are the ones who are administrators of this. So there is a national regulation. Maybe
Yeah.
the standards used are of from UK.
UK, that's okay.
There is a national regulation,
which is excellent.
So actually, I read the OSH Acts of 2007 from Kenya, and if you compare it with regulations from other countries like the US, the UK, or even in Norway, because I compared it with the Norwegian Work Environment Act, and they are quite similar. You find very many similarities. The problem comes when it comes to putting it into practice and enforcing it. That's where you'll start seeing clear differences between the practices in Kenya and the practices in other countries. But in itself, the Occupational Safety and Health Act, you'll think it's a copy of those which you find in other countries. And this is mostly, these are based on ILO requirements. So that's why they are very similar in nature. Any other question? Anybody else with any other question? If you don't have any questions, then I'll repeat what I said earlier when we started, because maybe some of you joined a little bit late. If there's a topic which you think that will be of interest to you and your colleagues and other professionals, you can let us know. You can send us an email to admin@oshproservices.org, or you can write the comments in the page where you logged in. And we'll try to see if we can accommodate that, if we can get an expert who can talk to us about that. Maybe we can get Dr. Mekonnen again some other day, because she's an occupational hygienist and she worked in many different areas. Maybe we can get her again to talk on a different topic.
Thank you so much. I would definitely will be happy to present again. I mean, no problem. It would be my pleasure, Abdul Kader, and it's great, excellent to be invited in an era like a place like this and give, present what my experience is in this topic so far.
Okay, now see we have a question from Mora. Is it a must for hearing aids, e.g. earmuffs, to have an indication of how much noise it's capable to reduce?
Hearing aid, you know, it's not a must. Like if it is over the 80 decibel average peak pressure level more than 8 hours in most countries in Europe, and in Kenya if it is over 90 decibel, yeah, it is a must. Because
So the question is if the earmuffs have an indication of how much noise it can reduce.
yeah,
This
and then
SNR number.
yeah,
Mm.
yeah, of course, that's very important because several providers you have thousands of hearing protective equipments, and not all of them are okay. Not all of them are excellent, of course. So the better, the higher this SNR value, the more the protection is. For example, when you go to the airport here in Norway or in other European countries, you find the hearing protection levels, the Peltor, the yellow one. So it has another SNR value, and it's attenuated to protect employees from noise from the aeroplanes, you know, which is extremely high. So you find different earmuffs based on for different professions. Like in some some international providers have different types of earmuffs, and they actually state what the earmuffs could be used to and what the SNR value is and so on. But in Norway, like I said, it's recommended that SNR value is recommended, and they have a standard of 12 decibel and 18 decibel, which is used here. So, yeah.
So it's very important to check also if the earmuffs which one wants to use will give a correct attenuation level so that the protection is complete. Thank you very much. Okay. Any other question? If there are no more questions, then I don't have anything else to add, but to thank Dr. Mekonnen for joining us in this wonderful presentation, and we hope that you learned something that you can take with you and use. And as she has promised that she would be happy to visit, to come again to give a presentation, and we will be happy to have. I see that somebody has proposed ergonomic training, chemical safety handling. We can organize that. For chemicals, it's very easy. I can get somebody to do for chemicals tomorrow, or I can do it myself because I deal with chemicals a lot. But we make a note of what you suggest: electrical safety, working at height. Thank you very much. All these are very relevant, and we make a note of this, and we'll see what we can tell. We plan to have another such webinar around the end of April. So we'll let you know the same way we did for this one, and yeah, I think that's about it. So look for the date of the next webinar. That will probably be around the end of April. With that, I will thank you again for attending and for being active, for putting up your questions and suggestions, and thank again to Dr. Mekonnen, and she will hear from us again very soon. So thank you and have a nice evening, and we hope to see you again in the next webinar. Take care and have a nice evening.
Have a nice evening, everybody, and happy Easter. Thank you. Bye.
Thank you. Good night.
Thank you so much.
Thank you and bye.
Thank you very much. Good night.
Thank you so much, Abdul Qadir, again. Have a nice Easter.
Thank you. Thank you.
yeah.
And I'll get in touch with you after we've done, we're done with this.
Okay. Thank you.
Okay. Bye.
Bye.